So this is the lesson for 12-4. All right, what you're doing today is solving a quadratic equation and determining the zeros. So you're actually finding two answers today. First of all, a product property that we have to talk about is anything multiplied by zero. Anytime that you multiply anything by zero, it's just zero. So like 0 times 5 is 0, 0 times x is 0. If we are going to distribute with a 0, it's just going to all equal 0. Sometimes they try and hide a 0 like this. 3 minus 3 is 0. So then again, you would distribute with that 0 and it would equal 0. So we're going to be setting things equal to 0 today. All right. In order to find the zeros, we have to set it equal to 0. These are the step-by-step instructions that you are going to follow for every single question today. All right. You are going to put the equation in standard form. So you need your biggest exponent to come first, then your x, then your plus or minus your whatever your plain number is. You are going to set the equation equal to 0. All right. Very, very important that you set it equal to 0 because that's how we're going to find the zeros. Sometimes you're going to be able to factor out a greatest common factor. Other times you won't. Then you're going to do reverse FOIL. After you do reverse FOIL, you're going to draw a line down the middle in between the two parentheses, just like I'm doing right there. And you're going to set each side equal to 0. Then you're going to solve that 1 or 2 step equation. Whatever answers you get there, those are the roots, the zeros, the x-intercepts. All three of these things mean the same thing. The roots of an equation is like the answer, the zeros are the answer, the x-intercepts are the answer of the quadratic equation. So when we take a look at these two questions, these are very, very typical of what you're going to be seeing today. So you have this trinomial, and notice that we have it set equal to 0 already. So the first thing that you want to do is reverse FOIL. What times what is 12? That adds up to -8. All right. What times what is 12? That adds up to -8. Well, it would be x minus 2 and x minus 6, because -2 times -6 is positive 12. -2 plus -6 is -8. So we did reverse FOIL. Now, the next step that you want to do today is you want to draw a line down the middle like that and set both sides individually equal to 0. So x minus 2 equals 0 and x minus 6 equals 0. So we want to set both sides equal to 0. And now you're going to solve. So this is just a one-step equation to get that x by itself. You would add 2 and add 2. So x equals 2. On this half, you would add 6 and add 6. So we get x equals 6. These are our two zeros, or our two roots, or the two x-intercepts. What picture I have down here is if we actually went and graphed this. If we put y equals x squared minus 8x plus 12 into your y equals, this is your graph that you would get. Now notice that these 2 points are these 2 points. We have x equals 2 right here. We have x equals 6 right here. So that's just a different way. This is doing it algebraically. This would be doing it graphically. All right, but this is how all the questions are going to look today. You're going to do reverse FOIL, draw your line down the middle, set both sides equal to 0, and solve for your two answers. Again, these things are called roots. They're called zeros. They're called x-intercepts. Take a look at the next one. X squared minus 5x minus 24. So what times what is -24? That adds up to -5. What times what is -24? That adds up to -5. Well, this one would be a +3 and a -8. Again, it does not matter. It does not matter which one goes first. You put the x minus 8 first, that wouldn't matter. After you do reverse FOIL, you draw your line down the middle and set both sides equal to 0. So x plus 3 equals 0, x minus 8 equals 0. Solve for x. So x equals 3 and plus 8 plus 8. So x equals 8. Again, if we went and graph this, this would be our parabola that we're graphing. This would be negative 3. This negative 3 is right here. That's where your 0 is, where it crosses the x-axis. And it's also at 8. That's where it crosses the x-axis. Those are your zeros. Those are your roots. Those are your x-intercepts. Now, these are the easy ones. They get much harder. All right, they get much, much harder. So take a look at the next one. In this next one, notice that we can't do reverse FOIL in this one because we have a negative in front of the x squared. All right, we can't do reverse FOIL. So anytime that you have that negative sign out in front, that is a good indication that we need to factor out the greatest common factor first. So we never want, when we go to do reverse FOIL, we never want it to be a negative x squared. So what goes into -1, -10, and 75? What we're actually going to have to factor out here is a -1. We're going to take a -1 out of each of those terms. So if we take a -1 out of here, we're just left with x squared. If we factor out a -1 here, -10 divided by -1, that would be a positive 10x. And then factor out a -1 from the 75. 75 divided by -1 is -75. So now this is actually what we have when we factor out the greatest common factor. Now you want to look and do reverse FOIL to the leftovers inside. What times what is -75? That adds up to 10. Well, what would happen here is we would have x plus 15 and x minus 5. 15 times -5 is -75. 15 plus -5 gives you 10. We're just going to leave this -1 outside. All that this -1 is going to do, it's not going to have any effect on our answers. It's just going to make the parabola open downward if we went to graph it. If we think back to last chapter, all right, that -1 out in front is going to make the parabola open downward. So again, all we're going to do is draw the line down the middle, set both sides equal to 0. And we're going to solve those. So -15 minus 15. So x equals -15. Plus 5 plus 5. And x equals 5. So again, anytime that you have that negative number out in front of the x squared, we want to factor out the greatest common factor. Take a look at the next one. Notice that this next one does not have a b term. Their b term here is equal to 0. Well, think back to the first part of this chapter. When it has a b term of 0, we want to look for the difference of two perfect squares. 9 is a perfect square, 25 is a perfect square. We have a minus sign in the middle. So this is the difference of two perfect squares. Square root of 9 is 3. So we have a 3x and a 3x because that's a perfect square. 25 is a perfect square. So one of them is going to be a plus 5. One of them is going to be a minus 5. Just like before, we're going to draw our line going down and set both sides equal to 0. Now this time, you're not going to be solving one-step equations. This time you're going to be solving two-step equations. So the first thing we'd have to do here is -5 and -5. So we have 3x equals -5 divide by 3, divide by 3. It's okay to get decimal answers in these. You will get some that are decimals. If you do -5 divided by 3, now you could just leave it as a fraction if you wanted to, -5 over 3, or you could write it as a decimal, -1.6 repeating. -1.6666666. 3x minus 5, we would do +5 and +5. So 3x equals 5. Divide by 3, divide by 3. You could leave it as a fraction, leave it as 5/3, or you could change it into a decimal and it would be +1.6 repeat. But you have to be able to recognize when it is the difference of two perfect squares. When it has a b term of 0, when your a term and your c term are perfect squares, and when you are subtracting. Take a look at the next one. Now, this next one is very, very, very different. Notice that in this next one, there is no c term, right? There is no c term in this one. Well, what the heck are you going to do when there's no c term? Well, when there's no c term, we need to factor out a greatest common factor when there's no c term, because I can't do reverse FOIL to that right now. I can't. So I have to do the greatest common factor. We have x squared and minus 11x. I can factor out an x from both terms. If I take away an x from both terms, I'm left with an x minus 11 inside the parentheses. Well, all that you're going to do here, and this one is very different, so please watch, where you're going to use this a lot. All that you're going to do still is draw your line right down the middle and set both sides equal to 0. This side is weird. All it is x equals 0. There's nothing to solve right here. You're just going to bring it straight down, and that equals 0. The other side, we're going to have x minus 11 equals 0. Just like we were doing before, and we're going to solve that equation. So we get x equals 11. So anytime that you factor out just that x like that, all that you're going to do is set it equal to 0. There's nothing to solve there. It's just x equals 0. Take a look at the next one. Now, in this next one, they love to try and trick you like this. What's different with this equation compared to all the other ones that we've had so far? Notice that in this one, it's not equal to 0. We need to get it equal to 0 first. So sometimes that requires adding or subtracting terms from either side. In order to get this equal to 0, the first thing that I need to do is add 7 to both sides. So therefore, I have x squared plus 8x plus 7 equals 0, because those cancel out. Now it's just a normal question. What times what is 7 that adds up to 8? Well, it is 7 and 1. Draw your line down the middle, set both sides equal to 0, and solve it. So -7 minus 7. We have x equals -7, -1 minus 1, x equals -1. There is a wide variety of questions with these. Even in the next one, this next one is even different again. Notice that we have 2 things on one side and 2 things on the other. Well, again, we want it equal to 0. So since we want it equal to 0, I'm going to get this right-hand side equal to 0, because I don't want a negative x squared term. So the first thing that you would need to do here is minus 13x and minus 13x. We would also have to do plus 81 and plus 81. Those cancel out, those cancel out. What we're left with on the right-hand side is nothing. Nothing in math is 0. So that's where we're getting our 0 from there. So on the left-hand side, we have x squared minus 18x plus 81. This is where we want to do reverse FOIL to. What times what is 81? That adds up to negative 18. Well, this would have to be a minus 9 and a minus 9. Draw our line down the middle. Set both sides equal to 0. Now, notice what's going to happen here. This is a very, very weird example. What happens here is that you get the same answer twice. We get x equals 9 and x equals 9. Every once in a while, you will get an answer that is like this, that's the same. What would this look like as a graph? Well, as a graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, you would have your parabola, your base of your parabola right there. So it only has one x-intercept. There's only one root. There's only one 0 because these end up being the same. Again, this next one is even more different. Again, can I factor out a greatest common factor? Does 3 go into negative 22 and does 3 go into 7 evenly? No. Therefore, when I go to do reverse FOIL, I have to have a 3x and an x. So what times what is 7? That adds up to negative 22, but whatever number you put here has to be multiplied by 3 first. Well, that would have to be a minus 7 and a minus 1. So draw your line down the middle, just like we have been. 3x minus 1 equals 0, and x minus 7 equals 0. Solve a two-step equation on this side. Again, you will get some decimals sometimes. You could just leave it as a fraction as well. We could leave that as 1/3, or you could rewrite it as 0.3 repeating. On the other side, we only have a one-step equation, so plus 7 plus 7. So x equals 7. Again, every question is slightly different, right? Every question is slightly different. Even in this next one, take a look at this next one. What's different here is that it doesn't have an equals 0 at the end. If it doesn't have the equals 0, you just have to add the equals 0 at the end. And now you're going to solve it that same exact way. However, you have an 8 here. Can we factor out the 8 out of all 3 of those? No. So therefore, it's either going to be an 8x and an x, or it's going to be a 4x and a 2x. Well, this one happens to be a 4x and a 2x. What times what is negative 21? That adds up to 2. You'd have to try a bunch of things. What it ends up being is a plus 7 and a minus 3. Again, draw your line down the middle, set both sides equal to 0, and solve. Minus 7 minus 7. So 4x equals negative 7. Divide by 4s. Again, you could leave this as a fraction, negative 7/4, or we could write it as a decimal, negative 1.75. On the right-hand side, plus 3 plus 3. So 2x equals 3. divide by 2's, x equals, you could leave it as a fraction, 3/2, or it would be 1.5. You can always graph all of these as long as you set them equal to 0 first and just see where the zeros are. On the Regents exam, they do make you show all this work, and they will specifically say to solve it algebraically. All right, so you do have to do it this way. What's wrong with the next one? Well, the next one is not equal to 0. So the first thing that we would have to do is +7 and +7 first, because we want that right-hand side equal to 0, not equal to -7. So you would have 3w squared plus 22w plus 7. Then you have to go through and do reverse FOIL. Again, I could not factor out a 3 using the greatest common factor to try and make it a little bit easier, because 3 doesn't go into 22 or 7 evenly. So I would have to have a 3w and I'd have to have a w. What times what is 7? That adds up to 22. Well, this would have to be a +7 and this would have to be a +1. 3 times 7 is 21, +1 is 22. Draw your line down the middle, set both sides equal to 0, and solve. Again, you are going to get some that are fractions or decimals. This one, again, is a fraction / decimal. We can leave it as -1/3, or you could write it as -0.3 repeated. On the other side, +7 equals 0. And then -7 - 7 to solve it, w equals -7. One more. 2 more. In this next one, first of all, it is not set equal to 0. You have to set it equal to 0. Now, in this one, you could, if you wanted to, just try and do reverse FOIL with a 3x and an x. However, I would factor out the greatest common factor to try and make your life easier. I see that 3 goes into 6 and goes into 45 evenly. So the first thing that I'm going to do in this one is factor out the greatest common factor. It's going to make doing reverse FOIL a heck of a lot easier. So if I take away a 3 from there, I'm left with an x squared, I'm left with a 2x, and I'm left with a -15. Those numbers are a lot easier, all right? Those numbers are a lot easier to do reverse FOIL with than trying to fool around with a 3x and an x. If you try and fool around with a 3x and an x with these, you're going to be looking at it for an awfully long time. -15 is a lot smaller of a number, so it's a lot easier to do reverse FOIL. So what times what is -15? That adds up to 2. Well, that would have to be a +5 and a -3. All that you do with your greatest common factor is just write it out in front. That won't make a difference in your answer, because now we're drawing the line down the middle. We're setting both of the parentheses equal to 0. So x + 5 equals 0, x - 3 equals 0, -5 - 5 +3 + 3. X equals -5 and x equals 3. In this last one, again, you want it equal to 0. Now, I wanted to put this one on here because it is a little bit different. We're going to get the 0 at the beginning of the problem by doing +2a and +2a. Just make sure that when you add the 2a over to the right-hand side, you're keeping it in standard form. So when we rewrite this, it would be 7a squared plus 2a minus 5 equals 0. Make sure that you put that plus 2a in the middle because it has to go in standard form where your biggest exponent goes first, then your next, then your next. This one ends up being 7 doesn't go into 2 or 5, so we have to go and do this with 7a and a. What times what is negative 5? That adds up to 2. It would be a plus 5 and a minus 1. Draw your line down the middle. Set both sides equal to 0. And solve. I would just leave the negative 5/7 as a fraction because that anything over 7 is an ugly number. Plus 1, so a equals. That is the process that you're going to do for every single question today. On your class kick, I did point out which ones you should do the greatest common factors with. So this is 12-4. So I do have an example there for you. So I think you just have 14 of these to do. Notice that in like questions 4, 5, and 7 here, I put factor out the greatest common factor. What I need you to do first is that reverse FOIL type looking thing, and then solve for the 2 letters. That's it for today. You are free to go.